there, I thought I would just make a quick video on how to answer this problem and problems like this. I will say that this is a very challenging Algebra 1 level question. While you will see word problems that get turned into systems, remember systems of equations, you likely won't see questions of this level on the SOL. You'll see questions of this type, so I don't want to say that this is not, something that we should learn how to do, but this whole like percent stuff being added, it's definitely an added layer, so to speak, to this problem. So the first thing, let's read it. It says Kevin wants to make a mixture that is 50% lemon juice and 50% lime juice. So think of a big pitcher of a mixture. That's the word they're using. I don't know, I think of like lemonade. And he wants half of it to be 50% lemon and, I'm sorry, the other half to be lime. How much 100% lemon juice should he add to an already existing juice mixture that is already 40% lemon and 60% lime? So he's got this pitcher. Let's see if I can draw a picture. Yeah, this is terrible. Sorry, guys. Here's a picture, a pitcher, and he already has this pitcher, and it has 40% lemon juice and 60% lime juice in it already. So he's got this existing pitcher, and he wants to make it 50% lemon and 50% lime. So he wants to sort of adjust these ratios. So you can see how the lemon is already less, right? It's at 40%. So he's wondering, well, hey, how much more lemon juice do I need to add in order for this mixture to be more balanced, to be 50-50? And the amount is going to be in gallons because he says he wants to make a total of 6 gallons of this solution. So sometimes it helps to sort of map out what we're, oh, this is terrible, what the hey, what we're working towards. We're working towards a 50-50 lemon and lime solution of 6 gallons. And so he's got to go from here to here. And how much lemon juice do I need to add? How much? And this whole 100% lemon juice thing, like, don't let that confuse you too much. It's just saying, like, that's all it is. It's just lemon juice. It doesn't have, like, anything else in it. It doesn't have sugar. It doesn't have water. It doesn't have anything. It's just lemon juice. It's 100% straight up lemon juice. Now, the other thing to point out is that he's only adjusting the lemon juice, right? He's not adjusting the lime juice at all. That's what the question says. How much lemon juice do I need to add? So that's going to be an important piece when we start writing out the equations because we're not so much concerned with the lime juice. We're more concerned with the lemon juice because that's what he's going to add to his current mixture. So we're going to write a system of equations, and usually it's a good idea to start out by identifying your variables. So we're going to let x equal how much 100% lemon juice we're going to add. So that's going to be the amount of lemon juice we add to the mixture. We don't know how much it is, so we're going to call it x. You can literally call it anything. I just picked x. And then y, we're going to let equal the mixture that we started with. Those are our two variables. How much mixture we started with. How much? Because we don't really know. We only know the percents. We don't really know how much of the current pitcher, how much is lemon juice. We know the percent of it, but we don't know how many gallons it is. We also don't know how many gallons the lime is, right? But remember I said we're not concerned with the lime because we're just adding lemon juice. All right, so our first equation is just going to be when you think of the amount of. So we have the percents, and then we also have the amounts. So we're going to have some amount of lemon juice added to some amount of the current mixture, and we want that to equal 6 gallons. So this is sort of our gallons equation. How many gallons of lemon juice plus how many gallons of the current mixture is going to equal 6 gallons total, because that's what we want. We want it to make 6 gallons. Now the second equation is where the percents will come in. So we have our general equation that we used, right? But we need to insert the percents now. Let me grab a different color. Okay, so remember X is the lemon juice, and the percent of lemon juice we're going to use is 100. So whenever you're using percents in an equation, you want to translate them to decimals. So 100, because we can't like type 100% on the calculator, there's no percent sign. So remember, to turn a decimal to a percent, we just move the decimal place 2 places over. So 100% as a decimal is 1, or 1.0. So we'll put the decimal there in front of the X because it goes with the X. And then how much mixture they started with, the Y. So we're going to add the amount of lemon juice to the mixture. So mixture we started with. And remember, we're only concerned with the lemon juice. So here's the mixture he started with. What percent goes with the lemon juice? And that's 40. So we're going to have a 0.4 here because 40%, remove the decimal 2 places, and that's 0.4. Again, we're not concerned with the 60% because we're not adjusting the lime at all. He didn't say, I'm going to add lime juice too. He said, I'm only going to add lemon juice. So we're only concerned with the part of the mixture that is including the lemon juice, the current mixture. All right, and then the total, we want the mixture to be a 50-50 split of the total gallons. So here we're going to have 0.5 times 6 because 50% is written as a decimal. Okay, that's the hardest part. Now that you have the two equations, you know there's multiple ways to solve this system. We could do substitution, we could do elimination, and we could graph it. So it's kind of up to you. I'm going to show you graphing because I think it's a worthwhile technique. So let me get our calculator up here. And all we do is put in those two equations, x plus y equals 6, and x, 1x is the same as x, plus 0.4 y equals 0.5 times 6. All right, there we go. Now we're going to see where they intersect. Where they intersect is the solution of the system. That means 1, 5 is going to work in both of these equations. It's going to satisfy it in both. If you took x equals 1 and put it into here, and see, 1 plus 5 is 6. And the same thing would happen down here. So 1, 5 is our solution. Let's see what that means. So this is the x and this is the y. So remember, x was how much 100% lemon juice. And that's what we're trying to find, right? How much 100% lemon juice does he need to add? He needs to add 1 gallon. 1 gallon of 100% lemon juice. That's what he needs to add. And there's already, let's see, how much mixture started with percent. That's going to be 5 gallons. So he needs to add 1 gallon of lemon juice to balance out that 50-50 split there. So our answer is 1 gallon. Again, I understand that these are challenging questions, but the process will roughly be the same every time. I feel like what made this question the hardest, personally for me, was this whole lemon or lime juice added in there. This was extraneous information. We did not need to use this at all. And sometimes problems will do that, and I know that's frustrating, but we needed to focus on what they were asking and what they were adding to the mixture. So we're adding the lemon juice, asking for the lemon juice. So we focused on all of the lemon juice stuff and the 50% lemon. That's where our numbers came out from. See, the 100% is the 1, 40% is here, and the 50% is here. And the x, again, was the lemon amount, so 100% is with the lemon. 40% was the lemon amount in the current mixture, so 40% in the juice mixture, and 50% was of the total of the 6. So that's why we have it with the 6. So as always, you guys reach out with any questions, and I hope that this helped a little bit. Bye!